just now. He suddenly and dramatically disintegrated 926 hertz at the end of the third minute of 926 hertz. Oops. There you go, let's watch live. This is real time. Complete total disintegration. Here we have a dramatic shape change right there, right before our eyes. See that? It's another one of those changes where it turns into a series of spheres and gets completely reorganized. Now this is in the middle of the slide, and it was, let's see, the SW 100 watts SWR 1.25, frequency 926, beginning of 926, so it could have been 925, but here's another total disintegration. And yet, not far from him, and look, this little piece of him is trying to swim away. That's amazing survival strength, isn't it? And yet, not far away, we see many who are not. So there he is. He's pretty small, so let's try to zoom in on him a little bit. There he goes. He's still slipping. Or is that piece of that one who exploded? I'm not sure. Could this be like J.H. Heller, who said that dielectrophoresis, a type of dielectrophoresis, could be used to create new organisms? Yeah, this is what's left of the other organism. Perhaps you can see the sort of fireworks effect happening in the growing blister to the right of the organism. And here comes a little neighbor, wondering what's going on, who's testing. And you can see blisters forming now on the lower left quadrant and upper left quadrant. The shape is now changing. And a major explosion out the top. You can see material being ejected from the organism. Its internal contents spilling out onto the slide. And if you look closely, you can see spheroid structures forming around the outside, some of which have broken off and are floating free in the debris field. (922 hertz). This is real time. First proof that using the Macintosh computer it is the correct scale. He's kind of a small guy. He's disintegrating in a very interesting way. Very unusual. This is proof that using my programs called RB Square Gen can actually be used to cause this effect. Fantastic. This is a very important proof, because now people will be able to use this program. Here's the end of a classic devitalization. That's probably part of him up there. And the other remnant is down here. We just missed it. It has all the classic signs. This is real time, 924 hertz, using a Macintosh computer. Check the scale is correct. There he goes, dramatic devitalization. We're going to just watch and see what happens. That's 924 hertz. He caught me a little off guard. He was so fast. Let's watch him. He's going to do a change. This is a classic. We have 100 watts, just a little over 100 watts. 110, 1.3 SWR frequency. And look, this part retained the cilia, just like yesterday's lab activities. July 6th, let me move that scale out of the way. A portion of the organism which normally has the cilia resealed itself. There it is, and actually still has some kind of motive power here. But it's hard to believe because you didn't see the transformation. So if it makes any difference in this organism, I'm changing the focus just a little bit to see what we have. Now, I don't know if that's an entire organ. It actually looks like a piece of an organism that already broke off from somebody else. He looks fragmented to me, like those other guys who fragment from a larger organism. No, that's not a complete organism. That's another fragment. We have a hit. We'll try to center him. Sorry, I went the wrong way. Here we go. There's a live hit. The scale is correct. This is in the upper right center of the slide. This took 2 passes. Here we go. We caught it live. This is live using the F125 program, which I have written and named Blepharisma 11F, using 2 frequencies that devitalize the organism. This took 2 passes. Let's go to 923. Oh wait, here he goes. He's changing in real time. This is real time. I'll try to keep him centered. He is moving while he's changing. Watch carefully. This is really interesting. 922 hertz, 125 watts, 1.4 SWR. He severed into 2 large spheres. He may undergo further changes. Let's watch for a moment. And oddly enough, something's moving. He's moving fast. Look at that. Little piece of him takes off. Like a, try to focus it. What's left of him is flying around the slide right there. Look at that. Incredible. There he is. It's too fast to photograph. There we go. That's 923 hertz with a 40% duty cycle. plus 10,164 hertz with a 50% duty cycle. We have a hit, finally. There he is. When did he give up the ghost? At 924 hertz with a 49% duty cycle. In real time, this is the two frequencies, 10,164, which is the 11th harmonic of 924. And the other frequency is 924. And this didn't really, even though over a dozen organisms completely stopped moving for the last 10 minutes or so, this one didn't really start to change until I reestablished this relationship of 924 hertz for one frequency and 10,164 for the other. 125 watts, 1.4 SWR. And this is real time. Classic change. Look at the left side of the organism over here. Dramatic, dramatic. There he goes. Ultra slow-mo change. See his tail? Right here? Very slow change. I bet if I change the power levels, it'll mess with him a little bit. Let's leave it and watch him. Slow motion change. What if I, in the middle of the change, what if I... Here's another one. There you go. Real time. Destruction. See his shape changing completely. That's 924 hertz, 128 watts, 1.45. Pushing our luck on the standing wave ratio. There's a whole field of them. Look, and right on cue, as the camera arrives, he decides to continue. I think he's continuing devitalization. 924 hertz. 120, it's 130 watts. Pushing our luck here in the power levels a little, but getting some nice results. 924 hertz plus 10,164 hertz. Running 2 copies of my program RB Square Gen. This one is interesting because it's a very slow motion kind of effect. There's several nearby organisms. There he goes. There's another one who's about to do similar. You might catch him. Watching the left side of your picture, you might see a small organism swimming by who's actually intended to be their food. He's devitalizing in real time. Very interesting that tonight, which is July 19th, we're getting sort of slow motion devitalizations. Maybe it's related to the power level. I don't know. Here we go. We got a nice video on that one. We're devitalizing in real time. Very interesting that tonight, which is July 19th, we're getting sort of slow motion devitalizations. Maybe it's related to the power level. I don't know. Here we go. We got a nice video on that one. Oh, a double hit. Double devitalization. Fantastic at 929 hertz. Both organisms going at once. Very rare to catch on video. Look at that. Fantastic. Let's give it a little red filter and look at some of the texture. So hope the camera doesn't flake out here. Stick with us here. Yeah, you see a little surface texture there. Look at that granulation of the remnant of the organism. Fantastic! Double devitalization at 929 Hertz plus 10,164 Hertz. The frequencies are being generated on the Macintosh computer and running a program I wrote called, and we have one in real time happening here, kind of slow motion, real time. I'll have to move the slide to keep them centered. And this disintegration is happening in real time, 927 Hertz. That's my first time I've seen that happen at 927 Hertz. 100 watts, SWR 1.2, 927 Hertz, ran for 562 seconds to start that. Plus, it's 927 Hertz plus 10,164 Hertz. Notice that the organism next to him is not doing this. This is kind of the mystery of this whole process. Not all organisms are affected. Look at the edges here. They start to take on a granulated shape and then they explode into a series of sphericals like that. And we have a hit. This is live in real time. Dramatic devitalization. I'm not going to center the slide so that you can see it. Here's the scale though. Scale is accurate. We have 925 Hertz, 100 watts, SWR 1.2, feeding two frequencies in, 10,164 Hertz and 925 Hertz. Now maybe we'll center it. I'm going to keep an eye out on any other nearby organisms. Okay, we have another one live. Devitalization. Let's watch it carefully. This is 925 Hertz plus 10,164 Hertz. 100 watts, SWR 1.2, and that took about 10 minutes actually. Disintegrating. This is very interesting. That's me centering. Oh, here we go in real time. These effects in August. These are happening in August. Monday, August 27th, 2007. Fell asleep. We still can see the end of the devitalization. It's happening at a very nice speed for photography here. Fascinating the way this is happening. Let's watch carefully. Sometimes a new organism is formed and swims away. I don't know if that'll happen. Let's see. He is completely disintegrated. Now I'm going to move it and center it a little bit. Okay. Let's watch it for a moment. The aftermath. And the scale is correct. You can see that some kind of action continues after the devitalization. There we go, one of the spheres exploded, another one exploded. And there's one large sphere left. Let's wait and see if anything in your screen. This is in real time. Real-time dramatic devitalization. Look at that. Incredible. Look at that. Forms hundreds of tiny little bubbles or spheres or blisters. Explodes into a series of... We have a little larger organism now. See if I can center them and focus. You're watching this in real time. Frequency is 926 hertz. I'll adjust the focus a little bit. 926 hertz plus 10,164 hertz. And he's been exposed for 625 seconds. So what's that, about 10 minutes? And this is happening in real time. The power level is 100 watts, wonderfully steady. SWR 1.2. Real-time devitalization of Blepharisma. First they are immobilized, and then they are destroyed, dissolved, or molecularly reorganized. We're not sure what. The apparatus that is doing this is a plasma light, helium gas stimulated by pulsed radio frequencies. There's a carrier frequency of 27 megahertz, and into that we do amplitude modulation of audio signals, 10,164 hertz and 926 hertz. And this is happening in real time. The plasma light causing this effect is about 5 inches away from the microscope slide. There are no wires attached, no metal plates. It's just we're having a great night here, filming devitalizations. This is live, in real time. I'll try to sharpen the focus a little bit for you. The scale is correct. This is about the 6th or 7th major reaction we've seen tonight. Let's see if we can get that sort of contrast effect we had before. Oh, I don't want to interrupt this process. There we go. Now you see a little surface texture. I'm cheating a little touch of red filter in there. This is a real-time devitalization of a Blepharisma using a plasma light, which is sitting about 5 inches away from the center of the slide. And here we've added a little touch of red filter. Here we see some action here. The end of the process. Explosion on top. Many spheres of many sizes formed. Look over here, you'll see tiny organisms swimming around. So he's not dehydrated, he's not been boiled, he's not been ultrasonically zapped. So we're actually connected in a V shape, a kind of a mating formation. And maybe this is what... Okay, we have another victim here. Real time. Just caught the last half of that one. That's a 929 hertz, which is my first hit at 929. Who is partially the way through the process. Oh, he's actually changing. Okay, let's watch him. Something's happening in real time with this guy. I need to check. Yep, the scale is correct. Yeah, watch him carefully in here. Some spheres are being ejected. And I think we're going to see a dramatic change. Look down here, something's breaking. This is 928 Hertz plus 10,164 Hertz. This is the first devitalization I filmed at 928 Hertz, which makes this very interesting. It's also pretty slow. Maybe you can see things are happening down in the bottom. He's sort of devitalizing in two directions simultaneously. Let's watch him and see what we can see. I think I'm going to center him a little bit. Hang on. Okay, now he's more in the center of the slide. And then I can do this little effect I'll cheat. Okay, watch the top. Here we go. Big changes here. Let's see if we can get a sort of a 3D profile effect here. Yeah, that's really nice. We'll try to focus that a little bit. Can you see that? That's a nice... You can see the surface beautifully in that. Very nice detail. 126 Hertz plus 10,164 Hertz. 100 watts. SWR is almost just slightly above 1.1. There we go, a live devitalization. Look how tough he is. He can swim and disintegrate at the same time. Watch carefully, I'm going to keep him centered in the scope. Look at that. Incredible. Now watch carefully. Oh, and look, there he's exploding on the run. Watch him, look at him try to escape. Incredible. They go from a small... Can you see that? Very colorful in the midst of quite a bit of debris. 100 watts, SWR about 1.1. 932 Hertz. First hit at that frequency I've seen. 932 Hertz plus 10,164 Hertz. You can pick that up. Excellent. 932 Hertz. Looks like an excellent frequency. Quite a few organisms. And he may have some... This is a real-time disintegration of a Blepharisma using a plasma light. The date is September 12th, 2007, and this has been a really interesting night of experiments because I've been finding, adding that, we take 10,000, there he goes, we take 10,164 Hertz, and then we add to that a range of frequencies starting at around 922 Hertz, 923 and so on. This is happening at 932 Hertz. So there's a little range in there within which the organisms will exhibit this behavior and show this effect. Now this is interesting. He's sort of half disintegrated. There he goes. Now he's going to finish. And we're seeing almost a fusion. Now the sphere separates again. Marvelous. There's a dramatic explosion out both ends at the same time. Complete disintegration. And let's watch the spheres because sometimes more activity happens. And, oh, we have another one right below it. We have to catch him. Here's another one live. 932 Hertz is the magic number. Ladies and gentlemen, this may become the new hot number for Blepharisma. 932 Hertz has taken quite a few victims tonight. 932 plus 10,164, 100 watts SWR 1.1. Fantastic. Powerful, powerful. And quite a few neighbors are not moving with real-time disintegration. Blepharisma. 932 hertz. He held out for quite a while. 1,041 seconds it took to break this guy down. Yet, many organisms are still living on the slide. But he has some neighbors who are not swimming. Here's one I believe is about to begin a disintegration. He has that look about him. Indeed, there he goes. I'll center the picture. It's a live disintegration, devitalization of a Blepharisma. September 12, 2007. We seem to have discovered a majorly important frequency of 932 hertz. We add to that 10,164, and by the way, 10,164 is the 11th harmonic of 924 hertz. So it would be interesting to adjust the 10,164 to make it be the 11th harmonic of 932 hertz and see if we get a dramatic change. Live, real time. Now this is a new frequency combination. The frequencies are 932 hertz, and then I just changed as an experiment the upper frequency. It is now 10,252 hertz, which is the 11th harmonic of 932 hertz. It'll be interesting to see if that's made much difference. There he is. Real time. The scale is correct. 10x objective. 10,252 hertz plus 932 hertz. So you have 932 hertz plus its 11th harmonic, 100 watts, SWR just barely over 1.1. Dramatic disintegration. Wonderful new frequencies discovered. 932 hertz plus its 11th harmonic, 10,252. There he goes. Quite a few people in the Rife community seem to feel that 3 minutes is plenty if you have the right frequency, and it looks like they might be right. Okay, we have another one, a little neighbor of the last one. This is happening in real time. Devitalization of a living Blepharisma, happening in kind of slow motion. It's being hit with two frequencies, 931 hertz plus its 11th harmonic, which is 10,241 hertz, and these are both amplitude modulated onto a radio frequency carrier wave of approximately 27 megahertz. This is happening on September 28th, 2007. We are getting an excellent devitalization of this organism. You're seeing the typical formations of spheroids. And this is fascinating. It's a sort of slow motion disintegration, emptying its contents out onto the slide, and now it becomes a little more dramatic there. It's going to completely dissolve, I think. Again, this is 931 hertz. plus its 11th harmonic, which is 10,241 hertz, plus a 27 megahertz pulsed radio frequency carrier. Here's another slow motion disintegration. This is the 10x objective. Oh, we caught it just in time. The action is happening. 927 hertz plus 10,164 hertz plus a 27 megahertz pulse radio frequency carrier. This is a Rife-Bare plasma experiment, and today is Wednesday, October 3rd, 2007, and we are seeing a classic disintegration here of a Blepharisma. 100 watts exactly, and the SWR is about 1.15 on the MFJ antenna tuner. And we have some beautiful video of this organism. We've seen organisms break up before with this combination of frequencies, 927 hertz and 10,164 hertz. And now you see you see that? Real time. And that's a new frequency and quite low, 462 hertz. That is an octave lower than any frequency ever seen. It's an octave lower than 924. So that's the first time we've ever seen that low of a frequency actually cause the effect. That is very interesting actually. Realization of a Blepharisma. This is a new frequency, 915 hertz. I decided to explore a little bit lower frequencies below the standard 924 and so on. 915 hertz plus 10,164 hertz. Real time. There he is. And this is the first official full disintegration with 3 frequencies. The 3 frequencies are 928 hertz, 10,164 hertz, and 13,860. The 2 higher frequencies are the 11th and 15th harmonic of 924. 924 being a sort of base frequency. This is happening October 7th, 2007. Kind of slow devitalization here. Let's watch it carefully. The frequencies are 932 hertz plus 10,252 hertz. That's my warning bell that I need to let my amplifier cool off. We'll just ignore that because we're getting some good video footage. I don't like to let the amplifier get too hot. It seems to lessen the effects. And we have a fabulous explosion. October 7th. Disintegration of a Blepharisma in real time with a pulsed Radio frequency plasma device. The plasma device is a long argon neon bulb. We're sending wonderful explosion from both ends. Classic, fantastic. 130 watts, SWR 1.3. Two frequencies are going in. Did you see that merging? We had just had fusion. Disintegration of a Blepharisma in real time. 130 watts, SWR 1.3. We're running two frequencies, 930 hertz plus 10,230 hertz, which is the 11th harmonic of 930 hertz. This is happening in real time. A pulse radio frequency plasma device is causing this. About an 18-inch long tube filled with argon and neon. Fantastic images. Dramatic explosion, disintegration of the organism. Let's watch for post-disintegration fusion of the spheres. Typically many spheres are formed when the organism disintegrates. Real-time devitalization of a Blepharisma. 930 hertz and its 11th harmonic, 10,230. And now we're going to stay with it and see if they fuse. There they go. Broke into spheres, and then the spheres sometimes fuse. Now I see the sphere formation. I don't have my scale right now. Great picture. Devitalization of a Blepharisma with a radio frequency pulsed plasma device. Two frequencies, 930 hertz and 10,230, which is the 11th harmonic of 930. 130 watts, SWR 1.3. Let's watch this closely. Usually we see spheres forming as the organism disintegrates. And sometimes, oh, there we got a double disintegration from the second end. Excellent, excellent. Classic. Now watch the spheres and see if any of them fuse together. Real-time disintegration of a Blepharisma using a long plasma light, an argon neon plasma light, about 18 inches long, 125 watts, SWR 1.3, two frequencies, 930 hertz and 10,230, the 11th harmonic of 930. This is a classic disintegration. Many small spheres being formed, and the organism is completely exploded from both ends. Fantastic. Of a Blepharisma. This is happening in real time. 130 watts, SWR 1.3. Two frequencies, 930 hertz and 10,230. 930 seems to be a tremendous number tonight. Total disintegration of the organism. looking at them under the Nomarski filter, I don't see any cilia action. This is just like before. And these little jerky movements are usually indicative of a morphological transformation. Current frequency is 1187 hertz. 1187 plus the 11th harmonic. Watch carefully, I'm just going to center the picture. This is a live morphological transformation of the protozoa Paramecium caudatum. The sudden jerky motions are most likely caused by, there you go, did you see that? There was a sudden little explosion internal. And there's a lot of activity happening inside the organism. We could zoom in, but we might miss the overall picture. Shall we take a chance? 513 seconds exposure at 1187 hertz plus. There's another big change. I'm hesitant to zoom in because we'll miss the big picture there. 1187 hertz square wave plus the 11th harmonic. It's about 110 watts. A little high for me, but tonight's been having good success at 110 watts. 1194 hertz. Let's see if in the next 7 minutes before I run out of video. Oh, see that jerky action? That could be indicative of a change about to happen. Keep your eye on that organism. This is classic. First they slow down, then they stop swimming. That's me just straightening out the slide. Nope, see that? Morphological transformation right there. We just saw it. He's changing live in real time for the camera. This is a morphological transformation of the Paramecium caudatum. 126 seconds, so we saw a change starting at 100 seconds. The frequency is 1194 hertz. Keep your eye on that organism. Continued changes. Morphological transformation of the protozoa Paramecium caudatum. I will try to center the slide. There he is, okay. As their shape changes, they sort of get pushed around on the slide a little bit. I can see the cilia. I don't see any cilia action. I wish to make note, oh, he's trying to get out of the picture there, that the first sign that you are on the right frequency is within 100 seconds, they will begin to slow down their swimming. Then they will quickly stop swimming. Then the external cilia around the perimeter, he continues to change shape and drift across the screen. Then, after they slow down and stop, the next thing that happens is the external cilia stop moving. You may see the mouth cilia still moving after the external cilia have stopped. In other words, the cilia around the perimeter of the organism stop moving first, and then the mouth cilia. Watch for constant changes. This is in real time. 238 seconds exposure, 1194 hertz, plus the 11th harmonic, about 110 to 115 watts, SWR 1.18, a bare Rife, or a Rife-Bare plasma device. Let's back out a little bit. Yeah, I think we're seeing a morphological transformation. That's why it's moving. He's transforming in real time. Very good. Just straighten the center of the picture a little bit for you. Morphological transformation of the protozoa Paramecium caudatum. July 23, 2008, caused by exposure to a Rife-Bare plasma device. The power is, we're up around 115 watts, which is a little high for my usual experiments. But we see we have an effect. Frequency is 1185 hertz plus the 11th harmonic. We've had about 300 seconds of exposure. We began to see the organism slow down and the first signs of change. We're definitely seeing morphological changes here. Paramecium caudatum, July 23, 2008, 1185 hertz, and the 11th harmonic, which is 13,035 hertz, 13,035, and we see internally a very large change happening. Some internal membrane just ruptured. Major changes in this organism at 1185. Continued morphological transformation of the Paramecium caudatum protozoa. This is live. You're seeing it in real time. It has undergone, excuse me, 460 seconds of exposure, and we continue to see changes in the organism. There may be other organisms changing at the same time, but we will stick with this one. Change the focal plane a little bit and see what happens. We might experiment a little bit with the DIC filter. Let's see if we could do that quickly. And here comes the last part of the DIC. And now we'll see interesting changes. I have to make a few adjustments here very quickly on the microscope. Here we go. Now we should have maximum effect of the DIC. There you go. So we'll be able to get very interesting texture and color information. You can see internally, we continue to have a morphological transformation. This was once a Paramecium caudatum. This is happening live. You're seeing it at the actual speed that it is happening. We're going to adjust some of the lighting a little bit to highlight various chemical constituents of the organism. Morphological transformation of a Paramecium caudatum as seen through an Olympus VX60 research microscope with a Nomarski DIC differential interference contrast filter. We continue to see internal changes in the organism. Let's continue to adjust the DIC filter, which reveals some of the subtle textural changes. There's a beautiful color. Hopefully that shows up on your video as beautiful as it is here in the lab. By the way, you can tell this is not thermal because you can see other small organisms swimming by. See if any other organisms were affected during this period. Now I've used this is the same organism you were looking at for the last 10 minutes or so, changing its shape, but in this case I've pulled out and I'm using only the 4x objective, so you see it in perspective, and look at all the tiny organisms swimming around on that slide. Many organisms still swimming, still alive. So this experiment was specific to this Paramecium caudatum and falls very close to a frequency range where we have seen this effect occur before. Somewhere between 1178 Hertz and 1200 Hertz, we usually can cause morphological transformation in paramecium, and if you add the 11th harmonic, it's a little bit more powerful effect usually. This is really interesting because that little sphere, which I would conjecture came from within the organism, is showing continued activity. This is very interesting. But this is a 40x objective, so this would be a little tricky to need to move that over a little bit so we can center the picture. There we go. Very touchy business. 40x objective. Oh, we're seeing a major change in the organism. So continuing. Now this is interesting because it didn't just separate, it quasi-separated and then came back. This is really interesting. I think we're going to stick with this for a minute. Current frequency is 1186 plus the 11th harmonic, but I believe that change actually occurred at 1185, but when we hit 1186 we got even more changes. That's the organism moving somehow, not me. As it continues to change shape, it is. That shape change causes it to move around a little bit on the slide. So continued morphological transformation of the protozoa Paramecium caudatum. Just look, oh, there we go. That's a nice color. And I think something dramatic is happening here, so we're going to stick with this guy. There may actually be another organism doing more dramatic things, but that shape is so unique and interesting, I can't believe it. And it continues to change. Here we see a paramecium, very much deformed, still alive. You can see the cilia beating here, but there's a blister, and of course it's not swimming at all. Looking at this through the DIC filter, hopefully you can see that. He's taking his time. Current frequency is 1168 Hertz plus its 11th harmonic, 12,848. Now we have a second blister forming up here, and this is a large blister. So let's watch carefully. 229 seconds on this frequency. Another blister forming, several along the bottom. Oh, here we go. Total destruction of the paramecium. Tremendous structural changes happening inside, openings in the cell membranes. Notice as the contents is released, the formation of the spheres. Now internal structure really completely destroyed in a paramecium. This was a paramecium. This frequency is 1168 Hertz plus the 11th harmonic, 12,848. Today is January 19th, 2008. This is about 110 watts, SWR 1.18. This is a Rife-Bare plasma experiment, and the plasma device is about 6 inches away from the microscope slide. We continue to see degradation in the organism. We're looking at this through a microscope filter known as a DIC filter, which gives us a nice sense of contrast and surface texture. You can alter the filter live. Now, this is with the 40x objective, and I think you won't see quite as much variation. We continue to see changes in the organism. It's completely unrecognizable now. Formerly a paramecium. This is a paramecium, and if you look carefully, you'll see there's some blisters in the bottom. Let me move them up just a little bit so you can see that. Another two more new blisters just formed on top. Here, and here's two blisters, and something just broke here. Oh, we have I believe he just exploded. There's material being vented, probably from the underside. Watch, the internal structure is all changing now. We were just lucky the camera was on. 200 seconds at 1170 Hertz, and its 11th harmonic, 12,870. And he is completely devitalizing in real time. Completely destroyed in a very dramatic way here. Look at that. Notice the spheres forming. Paramecium undergoing complete, utter, total destruction. Let me move them a little to your left there, so you can see it a little better. You see all those spheroids that formed? That's very interesting and unique to this process. We can probably highlight those outlines by changing the focus a little bit. Lots of spheres everywhere. And that is the end of a paramecium, caused by a plasma light. A Rife-Bare plasma device about 6 inches away. 110 watts. SWR 1.18, 1170 Hertz, and its 11th harmonic, 12,870 Hertz. Here's another organism, a paramecium, who has stopped swimming and is changing shape. This is the 40x objective. I guess I could put the scale up there. I haven't checked the scale today to see if it's right, but let's take a chance. I'll check it later. He seems to be changing shape using a special microscope filter. It's known as the DIC filter, differential interference contrast filter, which is supposed to provide different angles of light. DIC, and how the light travels through the organism. Sometimes the DIC filter is good for catching certain details. You'll see the colors are subtly shifting. Sometimes the DIC brings out different aspects of the organism. You're watching destruction of a paramecium in real time. Now you see there's been an internal destruction. You can see that the normal structures, internal structures, have been distorted, and now you're seeing blisters coming out on the organism and complete change. We're watching this through what's known as a DIC filter on the microscope. This organism is being subjected to two frequencies right now, two plasma frequencies. Watch carefully all the changes you're seeing here. The two frequencies are 1176 plus the 11th harmonic of that, 12,936. It's about 110 watts, SWR 1.18 approximately. And now I see no cilia action on the organism, and I believe is internally destroyed. We do see some changes though ongoing here. It's mostly the center portion of the tube, as you can see. Not quite. Very sensitive. This is 40X. You can see he's filled with lots of little holes. These might be cavitation holes, and I believe he's actually internally destructing. He's actually been exposed to several frequencies. I ran a sweep 1175, 1176, 77. This is now 1178. Each frequency for 5 minutes. He is, yeah, he's looking very much disturbed inside. I have had success before with Paramecium caudatum with frequencies between 1175 and 1178. He's now running 513 seconds. 100 watts, SWR about 1.3, using my old way of reading it. This is the 40x objective on the microscope. He's not swimming, which is usually a sign of some effect. And he's filled with many, many tiny holes. Now we're seeing some changes. We're going to watch him carefully. I have a feeling something dramatic will happen. Certainly seems to be changing internally. And you can see that. Sudden destruction. It looks like the contractile vacuole no longer functions. The sine wave, 600 seconds, 1178 hertz. Helium 20, 100 watts, SWR about 1.3. So this is about 10 minutes, 635 seconds, with a sine wave 1178. There's still some motion. There's an actual contraction there. I'm changing the focus a little bit on the microscope. We've seen these spheroid structures before with Blepharisma. You can see the organism is riddled with these holes, or little spheroids. It's very possible these are formed by some kind of cavitation in the organism. One theory being that fast-changing AC electromagnetic fields can induce ultrasonic waves in the medium or in the organism, resulting in this what may be cavitation. We'll stay in this frequency for a while. I might pause the camera. Same organism, but doing a sort of time lapse. Total duration is 835 seconds at 1178 hertz sine wave into a plasma helium tube, a long tube, 100 watts, SWR about 1.3. Oh, now we have a bubble on the upper left. The right, we are seeing possibly a breakthrough now in the cell wall. I would say this organism is devitalized. The primary frequency it seemed to be sensitive to was 1178 hertz, but it did undergo a sweep starting at 1175 with 5 minutes on each frequency. It's a sine wave input. Now you can see quite a bit of destruction. Tremendous morphological change of the organism happening in real time. And pretty soon I think the organism will be completely unrecognizable. We're going through a series of harmonics. Here's a big change. That's very interesting. 536 hertz. 536 hertz. It was already changing a little bit earlier. I'm going through a series of harmonics based on the frequency 134. So I'm actually going backwards through the harmonics of 134. This one started to respond at 804, which is a harmonic of that number. And then I went to 670, then 536. I'm currently at 536, and it is really completely devitalizing. 88 seconds at 536, but of course it was already undergoing a change earlier.